Okay, let's do this one. Now notice I had an angle with two sides. So when that happens, I always start with my angle to see if it's the bad word. So I drew my angle and it's like, yep, I get the bad word. You always want your unknown. This is like a hinge up here. You always want your unknown angle at the top, unknown length down here. And so then I kind of drew it, right? And when I do that, now, granted, I didn't draw it to scale, but 14 is kind of short. So I'm like, is that going to swing in? Is it not going to touch? It's not super long where it's going to go over. All right. So one thing you can do is set up law of sines. This again, bad word, ASS, right? PG-13. Math people call it SSA because, you know, when you teach high school, you can't say ASS, or middle school. That doesn't work well. I used to teach eighth graders. I know better, but you guys are college, or most of you are, at least your high school kids taking college credit. I don't know, but we're PG-13 here. So this is the bad word. That's when you can either get no triangles, two triangles, or just normal one. So one thing you can do is set up law of sines. This is your warning. I cross multiplied here. So what I did on a calculator is I'm going to take 25 times the sine of 87, and I'm going to divide by the number by the C. And so if you do that, you're going to get, let's see, 25. And notice we almost have a right angle, right? I mean, we're pretty darn close. Sine of 87, enter, divide by 14. And I get sine of 1.78. And if you're on autopilot and you're not thinking, you might do inverse sine to both sides. And again, you're choosing, which means, you know, you're not limited in domain. But notice if you do that, oh, you're going to get an error. And it tells you it's a domain error. So you might have caught it even before doing this step is, you know, sine, remember, and cosine are trapped between 1 and a -1 for ratios. This guy is outside of that. So this is impossible. So you know you're going to get no triangle. This 14 is actually too short, right? It's not, I mean, I made it touch, right? Because I wasn't, this is not to scale. But the reality is the reason I don't get even one triangle is it doesn't touch. All right. So what some people like to do is they like to test the height. Okay. So I came up here and I cut my triangle down the middle because then I have an angle and the hypotenuse, and this is a height, and I have a right triangle. So sine of 87 is opposite over hypotenuse, SOHCAHTOA. And again, if you like to cross multiply, just put a 1 there, and you can take that sine of 25, or sorry, the sine of 87 times 25, and you're just dividing by 1. So obviously that does not do anything. All right. And if you do that, so let's do that. So we're going to take 25, and this is telling you the minimum distance for that guy. So if you're like, I want to know, well, now you know. 24.97. So what that's telling you, 24.97, that is the minimum height to get a right triangle. Well, we're at what, 14? Is that what we had for this side? Yeah, 14. That is, you know, not even close, right, to 24.96. So it doesn't, or 97, it does not touch. Okay, now if it's, you know, a little bit longer than that, so say I get like maybe 25.5, right? You know, then it's kind of like, okay, well then, you know, it's kind of over here. If it has enough space to swing, when you do inverse sine, you'd be able to get two triangles out of that. Okay. And you can watch my other video on that. All right, let's look at this guy. I, you know, subtracted to get the other ones. Okay, so what is this? Side C and side B. All right. So if you try law of sines, you could do sine of 18 over B, sine of what? 145 over, what is that, 30, and sine of 17 over C. Okay. All right. So again, I could cross multiply here. Sorry, I typed that out in and I got a really crazy answer. So I'm going to take 30 times sine of 18. So 30 times sine of 18, enter, and then I'm going to divide it by the sine of 145. So divide by the sine of 145. That makes more sense. Okay, so B is 16.2 about, or I went, I guess, 1/6, depending on rounding. Okay, so this would be, that side would be 16.16, and I don't know if we have units on that. It doesn't look like it. Okay, C, I would not use my rounded value unless I use all of that, but I'm going to cross multiply here. Again, you're going to take this times this, so you're going to take 30 times the sine of 17, and you're going to divide it by what's by the C there, sine of 145. And you're going to end up getting what C is. Okay, so that would be this. And again, not drawn to scale. Only time you have to worry about no triangle, one triangle, or two is with the bad word. So if you don't have the bad word, you're good to go. All right. Okay, when do you get two triangles issue? Okay, it's the bad word. Okay, which math teachers call that, but if you put it in reverse, it's a bad word. And the reason it happens is because you have two variables that can vary together. So for example, if I give you 4 eighths and I put a 2 here, there's only one answer, okay? Because you only have one variable. So you're like, oh, divide by 4, that must be 1. But if I give you 4 eighths and I don't give you that, then you have infinite many answers, because this could be a half, this could be 3/6, it could be 7/14. I mean, it could be 40 over 80, because they both vary. There's lots of ratios that give you a half. Okay. So again, why does this happen? Well, all right, the two triangle issue is when this side over here is just a little bit longer than the minimum, and it can swing in and out. So if it's out, you have an acute triangle, but it can swing in and make a second and obtuse triangle. Okay, so that's kind of when that happens, when the minimum height, and this is just a little bit more. And so, yeah, you can have acute angle here if it goes out, and then if you slide it in, you can get the other one. Okay. All right. And again, usually what happens on that is you have, when you do inverse sine, maybe you get like, say, an 80-degree angle for when you have the acute, and then when you reflect it over your other one, so this would be what, 10 degrees, 10 degrees, maybe your other triangle has what, 110 for the obtuse one. Okay, that can happen. All right, I'm going to pause. We'll go to the next page if I can get my mouse to pause. All right, this one I just put ABC. It doesn't matter what it is, but I'm going to use the half with, again, you can use that when you have two sides with an angle trapped in between. You can use this formula. So it's half the two sides and then sine of the angle that it's trapped between. And again, make sure you're in degrees, okay, because that could mess you up. The other way you could do it is by Heron's formula, because you have side, side, side. This is the semi-perimeter when you add up the three sides, but you divide it by 2, because it's half, like a semicircle. It's half. So I get 13.2. You write that 4 times. So write it once with a parenthesis, and then put it in there, another parenthesis, and then another one, and put it in there. And then you subtract A, B, and C, and it doesn't matter the order. So subtract one side from it, the other side from it, and the other. Okay. And just be careful entering that in a calculator. If you don't have a very good calculator, you might want to just do the multiplication part and then square root. That's up to you. Notice I'm off by about 0.1, because of rounding. Okay. All right, let's look at this next one. All right, I'll just try to draw the picture. Tree is leaning to the right. Okay, so here we have a tree. It's leaning to a right at 100 degrees. We're going to attach a rope to the middle 5 meters up, so 5 meters. And then we're going to try to, pull it back, I guess, this way. Trying to get the tree to grow straight. The rope is making a 50-degree angle with the ground. So there's the rope. All right. How long does the rope need to be to make this work? How far should the post be from the tree? Okay. So I kind of want to know, I'll call this A and B. All right. I'm going to pause. I'm going to set this up a little bit. You try it on your own and then I'll go over it. All right. Okay. So the scraping sound, my dog decided to join me. So she's on the spare bed in this room, chewing away. So she has great teeth. She's 10 years old and she looks like she's a puppy, but she does like to chew. All right. I drew my picture earlier. I set up law of sines. again, when you cross multiply, what you're really doing is you're getting these two have to equal these two. All right. When you cross multiply, these two have to equal the product of those two. So technically what you're doing is this, and then to solve for B, you divide both sides. But a lot of times we just jump to this step where we take the two numbers that we know, multiply, and then divide by the one over here, kind of the odd man out, so to speak. So I did that for both. And again, once you get B, I don't like to use rounded numbers, so I skip and I cross multiply over here. So sine of 30 times 5 divide by the sine of 50, and I get A. So I got those two numbers. Now, what's reality though? How long does a rope need? How far should the post be from the tree? Well, the post should be 3.26 meters from the tree. The long, as far as the rope goes, I mean, this is the exact distance. If this is a post, I would assume you want to knot it around that a few times. So I think you're going to have to add something to it, right? So maybe a half a meter, maybe you need 7 meters so you have enough to tie it. So the reality is the exact distance is that, but that's not going to be enough to tie it around a post. So you're going to have a little bit more than that. All right, see if you can draw a picture and set up the next two actually, and then we'll go over those. Okay, so here's a picture of an actual map so you can see kind of what's going on here. Chicago's just not that far really from Milwaukee, and then the other two distances, right? And so again, I tried to draw this somewhat accurately on my piece of paper here. All right, so I kind of mimicked that, what was going on. Now, with law of cosines, you always want to put your largest side out. If you have side, 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 the only caveat is you want the largest side because your largest side has to be across from your largest angle, and then you can't have the two triangle issue. So if you have an obtuse angle, you're going to find it, okay? Because remember, inverse cosine is defined on the cap. So if you have an obtuse angle, you're going to find it. Law of sines, unfortunately, if you do inverse sine, it's on the side. You will not catch an obtuse angle. That's the issue. All right, so largest side, the other two sides squared minus 2 times those other two sides, cosine of B. All right, this is all glued together. There's no add or subtract in here. So what you want to get rid of is get rid of these. So subtract that, subtract that. So on a calculator, take 409 squared minus 92 squared minus 337 squared, enter, and you should get that one, okay? Then on your calculator, take -2 times 92 times that. Again, this is all multiplication, no adding, and then your cosine. All right, so once you do that, then what you want to do is you want to isolate your function. So now I'm going to divide. So I'm going to divide both sides by that. So I'm going to take my calculator and do 4, 5, what is it? 2, 4, 8 divided by -6, 2, what is it? 0, 0, 8. Daphne, stop it. And I get -0.7297122 dot 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 equals cosine B. Sorry, she's trying to make a nest. So she's destroying the bed while she makes a nest. Okay, now I am choosing to do inverse cosine, right? No one's forcing me, but that's how I solve this. So I'm not limited, but I'm gonna, if it's obtuse, I'm gonna find it. So it's gonna be great. So second cosine, second answer. Yay, it was obtuse and I found it. So that is good. So angle, which one did I just find? Angle B. All right, angle B is 136.9 about. 136.9 degrees. Now, is that the one I wanted? Find the angle. Darn it, they want the one with respect to Chicago. Okay, now, because I found the largest ones first, I can switch to law of sines. If I didn't do the largest side first, I'd have to do law of cosines again, just in case I missed an obtuse angle, okay? So let's see, I'm gonna pause. I'll probably, let's see, I'll do law of cosines again just because we've done a lot of law of sines. So I'll do law of cosines again up here. So give me a minute. I'm going to pause and I'll do that. All right, so we want cosine at Chicago. So I put Chicago here. The side across from that is squared. The other two sides go here, -2 times them and attached. Okay, this is glued together. You need to get rid of the adding and subtracting. So subtract this and this. So on a calculator, take that, minus that, minus that. You should get that, okay? Multiply all of those, you should get that number, cosine of C. Now you want to isolate this. You divide both sides by that coefficient. Those cancel. All right, so I get cosine of C. Now, I want to do the inverse cosine. Again, I am choosing to do that. My calculator thinks I'm on the cap, but it doesn't matter because all those angles are going to be fine for me anyway. So I'm going to, there's my angle. So I'm going to hit, or my ratio, sorry, second cosine of second, and it's going to spit out the angles. So I get what